Hey guys, so in yesterday's lesson, we talked about how to find the surface area of things like cones and pyramids. Today, we're going to be looking at how to find the volume of those shapes as well as the volume of cylinders. So for this, we will once again be using our formula sheet, but this time we will scroll down to the bottom of the page where the volume formulas are. So this is lesson 1.5, the volume of pyramids, cones, and cylinders. One important thing to remember is that when you're finding volume, you must use the height of a shape, not its slant height. So this is the opposite of when we're finding the surface area, where you have to use that slant height instead of the internal height. Now you need that internal height instead. Once again, you can convert between height and slant height using Pythagorean theorem, with slant height always being your hypotenuse. So that's your C value. And then just like with surface area, if you're given the volume, you can work backwards to find another missing variable. So once again, today we're going to go over two examples, one kind of working forwards to find volume and one working backwards when we're given volume. So the first example here, I have given you a cone. The slant height is 18 centimeters and the diameter across the base is 12 centimeters. You have been asked to find the volume. So I'll go over to my volume formulas and look up the one for a cone. And for that, the volume is 1/3 pi r squared h. So obviously, because I am dealing with my r value, I'm going to have to divide that in half. And then for my h value, like I said, unlike with surface area, we need to be using our internal height. So that is this height in here that would go to kind of the center of the base there and form a right angle. That's what I need to use for this h. So in order to do that, I'm going to make a right triangle like so. I already know that the hypotenuse, the side that's across from my right angle, is 18 centimeters. That's my slant height. The base of this right triangle here would just be half of the diameter, or the radius. So that is going to be 6 centimeters, since the diameter is 12. And then I'm going to need to use Pythagorean theorem. So that is a squared plus b squared equals c squared. My c squared does need to be my hypotenuse. And then my a squared and my 6 squared. Doesn't matter, of course, which variable you use. You could plug the 6 in with the a and solve for b too. Okay, so now I'm going to move my positive 6 squared to the other side. So I'm going to subtract 6 squared to cancel it out. And then, of course, what I do to one side, I need to also do to the other. So subtract 6 squared. That leaves me with a squared equals, and 18 squared minus 6 squared is 288. And then, of course, I need to square root to get rid of the squared sign. What I do to one side, I need to do to the other. So a is going to be equal to 16.97. So that is the height that I was looking for. Now that I have that, I can go over to my volume formula. My 1/3 pi isn't going to change. My r value is that 6. And then I'll times it by my 16.97. And you can plug that all into your calculator at once if you would like, or you can do the exponent part first to follow your BEDMAS rules and then multiply everything else. Let me just do that here. And I get 639.75, and volume is always in units cubed, so in this case, centimeters cubed. So that would be my final answer. And by the way, if you're not sure how to do 1/3 times pi, The way you would type that into your calculator is bracket 1 divided by 3, close your bracket, pi. So it would look like that. And then you can just type in the rest. Okay, so that's it for volume. It's much simpler than surface area because you don't have to add things together if you're only given one shape. Let's now look how we can work backwards if we're given volume. So that is the second example here. I've now given you a cylinder with a height of 14 centimeters. I've told you that the volume is 2200 centimeters cubed, and I've asked you to find me the diameter. So the first thing I'm going to do is go over to my formula sheet and look up cylinder. The formula for that is volume equals pi r squared h. I'm going to plug in my volume, so my 2200. I don't know what my radius is, so that's just r squared for now, and my height is 14. The next thing I'm going to do is you could divide away the pi and then divide away the 14 one at a time, but I'm actually going to multiply them together first just to save me a step of dividing. So I'm going to do pi times 14, which is 43.98, and then I still haven't touched my r squared. And now that I've done that, I have 43.98 times r squared. I can divide the number away from the variable, and of course I must also do that on the other side. So 2200 divided by 43.98 gives us about 50. It's 50.02. And then of course I just need to square root to get the r by itself. And I get 7.07. So that was my first step, was to use my volume formula, plug in my known values, solve for the unknown. That got me the radius. Because it's asking for diameter, my last step is just going to have to be to multiply the radius by 2. That's how we get diameter. So 2 times 7.07 will be 14.14. Is that true? Yes. Okay, and that would be your final answer. Okay, that's it for today's lesson. Let me know if you have any questions.